This video we're going to look at log graphs. Now log graphs are very useful to convert what would be an exponential graph into a straight line graph. So for example here, if you were to draw this graph, you would have C and maybe your A going vertically, and if you were to draw this graph, it might look something like this. So it wouldn't be very useful for you to find to do anything with. But what you can do is, if you take logs and you plot log C against log A, it will become a straight line graph. So from a straight line graph, then you can find the gradient and the intercept and so on. So let's just look through this process of how we actually do this. So how we convert from this curved exponential graph to a nice straight line graph, which we can use. Okay, so your equation was A is equal to B C to the power of D. So the C is to the power of D. Now if you take logs of both sides, you'll have log of A is equal to log of brackets B upon C to the power of D. And then we're now just going to concentrate on the right hand side. So splitting this up, that is log of B plus log of C to the power of D, which is then log of B plus D log C. Now we're just going to rewrite that so it becomes log of A is equal to D log C plus log B. Now this is similar to your y equals mx plus c equation. So y goes on the vertical, that means log A goes on the vertical, and then D is equivalent to your gradient. So this constant D is equivalent to your gradient, and your log C is the variable which is equivalent to the variable x, and log B is equivalent to your vertical intercept. I didn't say y-intercept this time because it's not a y-intercept technically, it's a vertical intercept just. So your x, variable x, is equal to your log C, your variable y is equal to your log A. So if you plotted these, you can see you would get a straight line, as we will see in the next couple of examples. Okay, we're going to look first of all, it says for the following relationship, express them in terms of logs and determine which variable can be calculated by considering the gradient of the relevant straight line by comparing with y equals mx plus c. So let's just get started, take logs. So let's just say, taking logs, you're going to have log of p is equal to log of b c to the power of n, which is going to be log of p is equal to log of b plus log of c to the power of n, which means log of p is equal to log of b plus n log c. And then all I'm going to do in this last step is just rewrite that as log p is equal to n log c plus log b. Now here, if I'm just going to write this, I'll write this in red then. If my pen would let me, I'll write this in red just to show me that's equivalent to, that is equivalent to my, that's being my y, and that's my mx plus c. So we can see here what we would do, we would plot log p against log c. When you say plot log p against log c, that means log p goes on the vertical axis, log c goes on the horizontal, and that is to get a straight line. Excuse my handwriting. So here in this case, that means n is the gradient. So n is the thing that's multiplying your log c. So n is equivalent to m. So n is the gradient. N is a gradient, and that is that one done. Okay, next example, same idea, just take logs. You're going to have log u is equal to log of v times j to the power of l, which means log of u is equal to log v plus, and I'm going to say that's l log j. So we just write that as log u is equal to l times log of j plus log of v. So again, I'll just write that in red below it. I'm just going to write my y equals mx plus c. And then it's easy for us to see what my gradient is in this case. So I'll just say before that, I'll just say plot log u against log j. And in this case, L is the gradient. And that's it. Okay, in this example it says the following log graph has been derived from the tables below. For the relationship v is equal to a r to the power of b, use a graph to find the values of a and b to one decimal place. And if r is equal to 5, find v to one decimal place. Okay, we've done an awful lot of work for you here. This would be the table you'd be given. These first two columns would be what you'd be given in exam, r and v. And you have to find then log r and log v. Let's just look at why we've actually found log r and log v. So you'd really do this bit of work that I'm about to do, you would do before you would find these two columns. So if you take logs of your thing up top, you'll have log of v is equal to log of a r to the power of b, which is going to be log of v is equal to log of a plus log r to the power of b, which is going to be log of v is equal to log of a plus b log of r, which means log of v is equal to b log r plus log b log r plus log a. I'll score that out. I'll get that fixed for your notes properly. So that's what you've got. So here the gradient is equal to b, and log a is the intercept. But why you find log r and log v, because you will have to get the straight line, you have to plot log v against log r, because this really is equivalent to your y equals mx plus c. So that's what it is equal to. So in this case, we're just going to say gradient is b. Right, to find the gradient, now I'm going to pretend, I always sort of pretend like I use the log graph. For these questions, you have to do the log graph. That's part of the marks for the question, is plotting this. So let's just look at this. We've got your v, and you've got your log v, on the vertical, log r on the horizontal. And notice the key thing here is I haven't started at the origin. If you were to start at the origin, folks, your graph would look like this. There's your origin, and you would just have a wee bit up here. So that's absolutely no good at all. So make sure you don't start at your origin. Start wherever your vertical values start and wherever your horizontal values start. And it gives it a more meaningful graph. It does, however, doing it this way, it does, however, mean you can't just continue this line on and see where it crosses the vertical axis. So just to find the log a part, we're going to have to do a wee bit more work, but we'll see that later on. Okay, if I was looking at the gradient from the graph, I would use the furthest away 2 points. Now, it's not brilliant, it's not very easy to use a graph, so what we're going to do is just cheat and just use this pair of values here and this pair of values here. So we're not really using our graph. The graph really is just there for us to show that it has formed a straight line effectively the way I do it. So I'm just going to say my gradient b is equal to, and I'm going to say it's my log v difference, so that's my vertical difference in this case, over my log, and what have I said, my log r difference. So my log v terms were 2.919, and the other log v was 1.991, and that corresponded to log r terms of 0.875 and 0.531. And if you do that, I got 2.7 when I did that out to one decimal place. Okay, what we then need to find is your a value. So you can do this two different ways. You could put your log v value in here, your log r value to find log a, and then do inverse log to find it. Or you could go straight to your original formula, so whatever way you want to do it. I'm just going to say v is equal to now ar to the power of 2.7. And when we know when r is equal to 3.4, your v is equal to 98. So just sub those in. That means 98 is equal to a times 3.4. Oh, I'll put that in a bracket, sorry. The power of 2.7. And that means 98 divided by that 3.4 to the power of 2.7 is going to be equal to your a. So that means I've worked out my a to be 6.3 to 1 decimal place. So I found my values of a and b. What I'm also going to do is rewrite my equation. My equation now is v is equal to 3.6 times r to the power of 2.7. Okay, I'm going to be using this later on for the last part of the question. Just read the last part of the question, make sure I've got it. I know I've done everything. I haven't. If r is equal to 5, find v to 1 decimal place. So we'll just say, we'll write down our formula again. V is equal to 3.6 r to the power of 2.7. So when r is equal to 5, v is going to be equal to 3.6 times 5 to the power of 2.7. So v works out to be 277.7, and that's, that's to 1 dp. Okay, you are now ready to do log graphs exercise, exercise 14a, and again that is from your CCEA